So let's begin our discussion on the atomic theory of matter. So what exactly is the atomic theory? Well, atomic theory states that all matter is composed of discrete microscopic units that are commonly known as atoms, and a group of atoms can interact with one another to form something known as a molecule. Now, the size of atoms and molecules is extremely small compared to the size of macroscopic objects that are visible to the naked eye. And because of the small size of the atoms and molecules, instead of using kilograms and grams to describe the mass of those atoms and molecules, we use a completely different unit known as the unified atomic mass unit, given by a lowercase u. Now, one unified atomic mass unit is equivalent to 1.6605 times 10 to the negative 27 kilograms. So we can see how small this unit is. We arbitrarily assign 12 unified atomic mass units to one carbon-12 atom. For example, 2 carbon-12 atoms will have a mass of 24 U. 3 carbon-12 atoms will have a mass of 36 unified atomic mass units, and so on and so forth. Now, one very common evidence that gives rise to the atomic theory is Brownian motion. So if we examine a fluid on the microscopic level, we will see that the individual atoms and molecules composing that fluid are in constant, rapid, and random motion. For example, if we take a small single particle of pollen and place it onto the surface of a fluid, let's say a liquid, we'll see that the surface molecules of that fluid will be moving and vibrating really quickly, and that motion of those molecules in the fluid found on the surface will cause the single pollen particle to also move in an arbitrary path, and this motion is commonly known as Brownian motion. Now, Brownian motion is a very useful concept. In fact, Albert Einstein in 1905 used this concept to essentially determine the radius and diameter of an atom, as well as estimate the mass of a single atom. So now let's move on to macroscopic objects. So these microscopic objects, the atoms and molecules, interact to form macroscopic objects. And there are 3 states that we should know. They are solids, liquids, and gases. Now there's a 4th state that is known as plasma, but we're not going to concern ourselves with that in this lecture. We're only going to look at solids, liquids, and gases. Now, generally speaking, each one of these macroscopic states has its own properties, as we'll see in just a moment. And these general properties are a direct result of the way the individual atoms and molecules interact with one another on the microscopic level. So let's begin our examination by looking at solids. Now, in a solid, the individual atoms are held together by relatively strong electrical forces. So the electrical forces are a direct result of the charge in the electrons and the protons. These negative and positive charges interact with one another, forming the following crystal lattice. Now, crystal lattice is simply the following shape of the solid macroscopic object. Now, because of these relatively strong electrical forces, the atoms and molecules found inside the solid object remain close to one another, and each atom and molecule is under constant vibration or oscillation. So, if we examine, for example, this atom or molecule found inside the solid, we'll see that its position is relatively fixed. What that means, even though it oscillates or vibrates back and forth, it vibrates about a fixed equilibrium position. Now, let's move on to liquids. In a liquid, the electrical forces that are holding the atoms and molecules together are weaker than the electrical forces in the solid. And that means each atom and molecule is able to move about more freely and rapidly. So if we look at the solid, our atoms and molecules are fixed in relatively stable positions. But because of the weaker electrical forces in the liquids, these atoms and molecules are able to move about in Brownian motion. Now, if we examine gases, in a gas, the electrical forces are extremely weak compared to the forces in the solids and liquids. And that essentially applies that the speeds of the gas molecules and atoms will be extremely high. In fact, the electrical forces are so small that usually we can neglect these small electrical forces. So in a solid, we have a relatively fixed position and the atoms vibrate about a fixed point. In liquids, because of the lower or weaker electrical forces, the atoms are able to move about in Brownian motion. And in gases, the molecules move with much faster velocities, also exhibiting Brownian motion. And this concept of Brownian motion helps us explain the atomic theory of matter, which essentially states that all matter is composed of these individual discrete particles known as atoms. So atoms collectively interact with one another to form macroscopic objects, which divide into three types: solids, liquids, and gases.